Hello students, welcome back. Now let's begin something called Bayesian analysis, at least the simplest and the most elementary version of it. It's based upon conditional probability computation like this. Let me expand the font a little bit. There are too many fractions here. Now, when a sample space can be decomposed by two events, B1 and B2, and nothing else, then either B1 happens or B2 happens. And based upon those conditions, we're going to get conditional probability. Probability of A given B1, it's right here, or probability of A given B2. But then again, what if I want to switch those two? A already took place, and what if it came from B1, basically going back in time? So if I switch the condition, in that case we end up with this formula there. That's Bayes' theorem. And the proof is, as a matter of fact, kind of like this. B1 and then probability of A given B1. Getting this? Okay. So that is the numerator here. See that? Now, probability of A. How do you get probability of A? Well, we have this decomposition, so either B1 or B2 always happens. So it's going to be either this or that one down here. So this one up here will be the first, and that one down here, A and B2, is going to be second. If you followed all those proof, yes, actually it was proof. I gave you through a tree diagram, but actually it was full proof. If you followed all that, it's great. If you didn't, that doesn't mean you still cannot use this formula. You can still use it. Now, what if you have more complicated decomposition? And if you have three events, B1, B2, B3, and for example, A came from B1, well, here, that's a numerator, and it must have came from this path, multiplication rule. And then the denominator, P of A, somehow it happened. It's all blue, this one, and the next blue, and then the next blue. You see? A must have come from either B1, B2, or B3 because there's nothing else there. And then the first one, this one, is in the numerator here and also here. And second one down here is this one. And third blue here is this path. Now, what if you have not just 2 or 3, but many more classification? In that case, similar kind of formula works. One goes here and then all the other. But then again, oh wow, there are too many symbols. It's really difficult to understand how things are going. So let's try this using an example problem. And let me switch the order a little bit. Let me do this 2.5 before 2.4 because we just went through this in previous video. An auto insurance company classifies its customer base as minimum risk, low risk, moderate risk, and high risk, depending upon their driving records, and so on and so forth. Exactly the same as before. If necessary, stop the playback and read through. Okay, part A. Find the probability a randomly selected driver of this company gets into an accident within a month, which is actually the same as example 2.2. So, here we have this tree diagram. So either going to this path, high risk collision, moderate risk collision, or low risk collision, minimum risk collision, one way or other, we're going to get collision. Right? So, let's put all those numbers in. Okay, all right. Numbers in. These are given here. 10%, 50%, 30%, 10%, all right. And then for collision, 10%, 5%, 3%, 1%, all right. And then this problem is all about getting into an accident, so let's not bother with no collision case. And then let's apply the multiplication rule. Basically, we can follow the path, for example, like this. It's going to be multiplication. This times that. You see, it's going to be a multiplication rule. For example, if you're following this path, this times that. Remember, tree diagrams are all about multiplication rules, and you have to do this for each collision. There are 4 of them. So this is what you get. Calculate all those for collision, and you don't really have to bother for no collision case, but I did it anyway, and then add them all up. Then that's a probability that collision took place. So this is the answer for part A of the problem. This one I just have it, but actually this is the answer part A was looking for. Now let's go to part B of the problem. Let's look at the conditional probability. If a customer selected had a collision past month, so this is a condition now, had an accident, what is the probability this was a low-risk driver? Look at all these. These are conditional probabilities, but conditions were minimum, low, moderate risk, and high risk. Those are conditions. Now, condition and the other were reversed. Now condition is collision. Had an accident, so probability of low-risk driver given an accident took place. That's a problem here. By the way, the probability of accident took place given it's a low-risk driver is given as 0.01. You see? No, low risk is 0.03, excuse me. 0.01 was minimum risk. You see, this one over here is actually this probability down here. Not this one. Basically, we are switching the conditions. So how does it work out? Here's a hint. The tree diagram, of course. And then we are looking for the probability of, let's see, low-risk driver given an accident took place. Let me use collision. Then that's probability of low-risk driver getting into collision over probability of collision. That's the definition of the conditional probability. By the way, I don't like this expression very much. Okay, let's write like this. Some more. Okay, all right. And then this one we just calculated previously. And what is this? It's going to be one of those branches. Here we go. Tree diagram. And this is what we are looking for. Let's copy and paste. This is what we are looking for, remember. How to get all those collision, all those red. Let me copy and paste here. How do you get collision? All these red. And how did it come from low risk? It's this particular path among all those four. So this one, highlighted in bold here, over all red. So down here, all possible collisions, so 0.01, 0.025, plus 0.009, plus 0.001, all those red put together, and among them, only one of them is the one I really want. The one came from low risk. So down here, all possible collisions from all four categories appear among those four possible collisions, one that I want, the one that came from low risk drivers. So here's a computation. See, computation, down here all these, and then up here, this particular one, which I just highlighted in bold, this particular one. Here's a complete tree diagram, and this bold, that's the branch I want over all possible branches. Make sense? The denominator is all possible branches. Now you have to read the problem carefully and then find one particular branch, one particular path rather. Now, how about the next problem here? It's got to be similar. If a selected customer had no collision past month, what is the probability that this customer was a moderate risk driver? So this time we have to consider no collision. So you have to consider that blue case. Let's see, here we go. So no collision past month, and then it came from moderate risk driver. Let's use some path highlighting. Let me try my best. Okay, we are particularly interested in the moderate driver case. So and then having no accident, right? And this is the part that I am particularly interested. And this is going to be the numerator of that probability. Okay? The probability of that event I want is the numerator, and denominator is total, basically. And this one is the one I want. We know no collision, all right? So we have to consider all no collision cases. There are four possibilities. Among all those, this is the one I'm particularly interested. Now, otherwise it's going to be these. This one, this one, this one, and of course this too. So in order to get this, you have to follow the path. Follow the path, follow the path. You need four paths. And then among those, this one is particularly important. Let's see. You get all those. And eventually what you're going to get is, let me see. Okay, the first case, and then the third case, and then fourth case, and then this is the case I'm particularly interested in. Okay, this is a computation we need in the end. Let me see. I hope I'm not slowing things down too much. That's number 1, so that's number 1, and that's number 3, and that's number 4, and then this one is the exclamation mark that I make. Okay, that's the exclamation mark that I am particularly interested. Oh, well, whatever. So out of 4 possible ways to get no collision, the one that I'm particularly interested in is the one coming from moderate risk, the one highlighted in green here. So that's the computation I'm going to do in a moment. All right? Okay, there you go. All right, here is a tree diagram with all those information. Okay, numbers are all in there. Now, how about the complement probabilities? We need all those. So 90%, 95%, 97%, 99%. They were not directly given, but you can easily find those out from complement probabilities. And then the one I'm particularly interested in is moderate risk driver getting into no accident for the month. So get this probability here in blue. And overall, no accidents, all 4. So what do we have? Sum of all those blues, all those down here, all those, yes, okay, no collision, all those. Among those, the second one is the one that I'm particularly interested, which came from no risk driver, moderate risk drivers. And here's a computation. So this is an example of Bayesian analysis. The denominator consists of all possible paths. Here 4 branches, so 4 possibilities. If you have 3 branches, 3 possible, and then 9 branches, then 9 possible paths, they all added together go to denominator. In the numerator, I have to select one particular path that I'm interested. This problem explicitly said moderate risk driver. So that particular path goes to the numerator. You see all 4 of them are down here. That goes to the denominator. And one of them goes to the numerator as well. That's how you do Bayesian analysis computation. Okay, it was a long problem, so I ended up doing only one problem in this entire video, but I'm going to do another example problem. Alright, see you soon for the next problem.